So in this video, we will continue solving problems from exercise 7.1. Here we are going to deal with problem number 3. Let's read what the problem is. AD and BC are equal perpendiculars to a line segment AB. So this is line segment AB, okay, and AD, okay, let me use a highlighter, and AD and BC, they are perpendiculars to this line. So here is the perpendicular mark. Also they are equal in length. So you can see BC is equal to AD. Okay. Show that CD bisects AB. So CD is this line. Let's use a highlighter. Okay. So CD is this line which will bisect AB at point O. What do you mean by bisect? It means it divides the line CD in two equal parts. Okay. So in other words, we have to show that OD is equal to CO. Okay. Now I'm going to erase this highlighter thing so that we can proceed. So just to revise, okay, we have to show that CD bisects AB. That is, we have to show, okay, OD is equal to OC. Okay, that's what we have to prove. If we prove OD is equal to OC, then we can prove that CD is bisected by AB. Okay, so in order to show that, we have to use the congruence of triangle concept. If we prove that this triangle ODA, now again, let me write down the names. If we prove triangle OAD is congruent to triangle, okay, now note I have gone OAD, let me use a highlighter, OAD. So I should go in the same order, which will be OBC. Okay, so OBC. If we prove, now focus on this statement. If we prove that OAD is congruent to OBC, then we can easily say that OD is equal to OC. And if we say OD is equal to OC, then this thing is proved. And once we say OD is equal to OC, then we can say that the whole CD is bisected by AB. Okay, so this is how we are trying to understand what we have to do. Once we are clear and confident about what we have to prove or what we have to go in our approach, then we can go and start solving the problem. So once again, let's remove these highlighted things. Okay, so now our problem statement has reduced to proving that OAD is equal to is congruent to OBC. Now as you can see in this, we already have some pieces of information. First thing is, we know these two angles are congruent to each other. Okay, so I'm going to mark here A is congruent to B, so that is known to us. Then the second thing known is AD is congruent to BC, so I'm going to mark here AD is congruent to BC. Now we just need a third thing to prove it, that these two triangles are congruent. From now, look at this figure. From the figure, it's a bit obvious that here we have vertically opposite angles, and we all know that vertically opposite angles are always equal to each other. So I'm going to mark them now. This angle is equal to this angle because it's a vertically opposite angle. So we have two angles. This is one angle, this is one angle, and we have one side, and thus it will be a AAS congruency of triangles. So let us proceed with our proof. First, once again, let me just get rid of this so that's easy to proceed. Okay, so this is going to be our steps of proof. First of all, we will say that angle OAD is equal to angle OBC. Why? Because this is given. Okay, they are right angle triangles. Then the second step is going to be side AD. Okay, this AD is equal to side BC. Okay, again the order in which we note or in which we write is very important. So again this is also given. And the additional third thing which we have figured out is the vertically opposite angles. So I'm going to say angle, now this is angle O. Okay, this is at angle O. So the way we are going to write is DOA. Okay, so angle DOA is equal to, once again, COB is equal to angle COB. Why? Because they are vertically opposite angles. Vertically opposite angles. Okay. Now, thus we have two angles. Okay, two angles and one side. So by, okay, thus, let's move. Yes, thus by angle side congruence test, we can say, again, focus on the order. The order is important. We can say triangle OAD is congruent to triangle OBC. Okay, and once we have said this, once we have proved this, then we can easily say this part, OD and OC. So let me use the highlighter once again. So OD, and this is the OD, and this is our OC. Okay, and therefore I'm just going to continue, and thus after this, so once we prove that two triangles are congruent, all the three sides and all the three angles of both the triangles are also congruent to each other. So and thus side OD is equal to side OC. Okay, and thus in other words, now we are going to copy the problem statement given to us. Thus in other words, this one, CD bisects AB. So that's what we're going to write here. Thus in other words, CD bisects AB. Okay, so quite simple. So let us quickly revise what we did or how we approach. First of all, when they told us that CD, we have to prove that CD bisects AB. Okay, we did this conclusion that we have to show OD is equal to OC. That was the first important conclusion in our process of solving the problem. That in order to prove this statement, we have to show OD is equal to OC. Okay, and in order to show OD is equal to OC, we thought that we should prove that OAD triangle is equal to OBC. And the order in which we wrote this is very important. OAD, OBC. Then we quickly noted down 3 points and we used a AAS test to show that the triangles are congruent. That was the flow of thought or the approach in which we solve this problem.